Elon Musk is a man who knows the value of hours. He plans to start sending his to Mars soon. This requires traveling deep in space with all the dangers for at least 5 months. Musk can't do anything about his distance from Earth to the Red Planet, so he can only reduce his travel time by increasing the speed of his spacecraft can travel. If spaceships could travel faster than the speed of light, most of the mass problems would be solved. But CEO thinks it's a terrible idea. In this video, Elon Musk shows why he thinks it's bad for you to travel faster than the speed of light. Many would hesitate at the idea he would move 1 million people from one continent to another, but Musk is doing his transfer on a large scale. His goal is to transport millions of people from Earth to Mars, where he will permanently reside, and importantly, he wants to do it in a short period of time for reasons. The main reason for this is that space is filled with powerful, harmful radiation. Prolonged exposure can be detrimental to health or even fatal, can even be sterile. Staying in low gravity for too long can cause serious health problems, including muscle loss and bone damage, making it a double hit for radiation in low gravity. You don't have to spend so long in space when something could go wrong at any time, but you will end up on your own. There are issues here. The spacecraft is very fast, but all Musk can do is target the window with the shortest distance separating Earth and Mars, but is that all he can do? What if he could move his spacecraft faster than the speed of light, drastically reducing time travel? What could go wrong? But what exactly is the speed of light and how fast is it? Some people can't stop thinking about how fast the light traveled. When you turn on a light bulb in a dark room, they simply accept that the room is no longer dark and go about their business. You're not who first thinks the light is fleeting or that just happens. Aristotle, his famous 5th century Greek philosopher, also believed that light travels. Was not the fact that he wrote an entire treatise on sensations and sensitivities was a rebuttal of Empedocles, another philosopher who believed that light could travel. But thanks to science, we can now multiply Aristotle, because he knows the exact speed at which light travels. The value is 299,792,458 meters per second, 186 and 2 miles per second, or 2,099,700 kilometers per second. On Earth, when he reaches light appears instantly, so anyone casually observing light effects can get lost in their journey. However, in space, where the distance is vast, it begins to matter, and this makes him a place that is daunting. To say the least, talks about the concept of light. What are light years? This is the distance unit of measurement and is in fact the unit the scientist uses in his universe to measure his far distances. A light year is the distance light can travel in 1 year, approximately 6 trillion miles and 10 trillion kilometers. This is what it means. For example, light travels from the moon to the eyes in about 1 second. This means that moon is about 1 light second away. The sun is about 8 light minutes away from her because it takes about 8 minutes for sunlight to reach her eye. However, the light from Alpha Centauri is the closest star system of our own. It takes about 4.3 years to reach Earth, so the light on Alpha Centauri is 4.3 years away. Even better, to get an image that is light years in size, the distance is around the circumference of the Earth, which is about 24,900 miles. Line it up with a straight line and multiply the length of the line by 7.5. The corresponding distance is light seconds. Then place 316,444 million similar lines end to end. The resulting distance is approximately 6 trillion miles. There are objects even more distant than Alpha Centauri, like the stars beyond the solar system. They are at years, billions of light years away. So everything astronomers see in the faraway universe is literally history. When an astronomer examines his distant objects, the objects appear to exist in his hours when the light left them. So this group expert is actually dealing with his date he is years old. This principle of going back billions of years allows astronomers to see how the universe appeared after the Big Bang, which happened about 13.8 billion years ago. Objects that are 10 billion light years away appear to astronomers as they looked 10 billion years ago, relatively soon after the beginning of the universe, rather than how they appear today. What happens when you travel faster than the speed of light? This is going to be great, so hold on. If you travel faster than the speed of light, you can go back in time. In this case, for example, the result could go back to the point before the cause occurred. Baby rocks before hitting. Or if a football game is on and is being broadcast live, you can go to the edge to see the final score before the referee blows his final whistle. However, don't get carried away with the psychic powers you possess, as you will have to deal with some annoyances with for example, it is unknown what the light would look like if you walk past it. Therefore, the final results of football matches may not be displayed. Another thought about traveling at the speed of light is that if something is traveling faster than the speed of light, you won't see it until, say, a plane made of neutrinos passes by you. The light it emits strikes behind it. The neutrino facet is only visible after passing through them and only if it contains that reflects or emits light. And just as an airplane passing through a sound barrier emits a sonic boom, A superluminal aircraft passing at the speed of light emits a flash. There is another phenomenon that happens when you move at the speed of light. This leads to Albert Einstein's famous equation, E is equal to mc squared, where E is energy, m is mass, and c is the speed of light. According to this formula, mass and energy are the same physical quantity and can be converted into each other. Because of this equivalence, the energy a body has through its motion increases its mass. In other words, the faster an object moves, the greater its mass. This is only noticeable when the object is moving very quickly. If you move at 10% the speed of light, let's say its mass is only 0.5% more than would expect. But if you move at 90 the speed of light, its mass doubles. When an object approaches the speed of light, its mass increases rapidly. If an object were to move 186,000 miles per second, would its mass become infinite and consume the energy required to move it? But what if you were moving at nearly the speed of light? That is very interesting. A famous result is a delay of hours. This shows that time goes slower when an object is moving very fast. Flying with a rocket traveling at 90% of the speed of light halves the timing. The clock only advances 10 minutes, but more than 20 minutes have passed. As an observer on the ground, I also experienced some strange visual results. One such result is aberration, which refers to how your entire field of view shrinks into the small tunnel-shaped window in front of your spacecraft. This happens because the photons look like tiny packets of light coming in from behind you in the forward direction. You will also notice that an extreme Doppler effect occurs, causing light waves from the star in front of him to cluster together, making the object appear blue. Light waves from the star behind you appear red with spreading out. The faster you run, the more extreme this phenomenon becomes, until all visible light from the star in front of the spacecraft and the star behind it is completely shifted. From the known visible spectrum, which is the color that humans can see, these stars appear to simply darken or fade into the background when they move out of the detectable wavelengths. Now let's go back to traveling at speeds faster than the speed of light. Is it really possible? The answer, sadly, is no. According to physicist Albert Einstein's theory of special relativity, on which much of modern physics is based, nothing in the universe can travel faster than light. The theory states that matter approaches the speed of light. The matter's mass becomes infinite, as we have shown you in the equation earlier. This means the speed of light functions as a speed limit or cap on the whole universe. The speed of light is so immutable that according to US National Institute of Standards and Technology, it is used to define international standard measurements. You might not realize it, but common measurements like the meter, the mile, the foot, and the inch are all tied to the speed of light. It is the same speed of light that helps define the kilogram and the Kelvin. Here are some more interesting tidbits about light travel. Although the speed of light is taken as the universe's speed limit, the universe actually expands even faster. The universe expands at a little more than 42 miles or 68 kilometers per second for each megaparsec of distance. From the observer, a megaparsec is 3.26 million light-years. In other words, a galaxy 1 megaparsec away appears to be traveling away from the Milky Way at a speed of 42 miles per second or 68 kilometers per second, while a galaxy 2 megaparsecs away recedes at nearly 86 miles per second or 136 kilometers per second, and so on. Also, even though you can't travel faster than the speed of light, you can slow down light. This is high school physics. Really, the amount that a material slows down light is called its refractive index. However, you can trap or even stop light inside ultra-cold clouds of atoms according to a 2001 study. More recently, a 2018 study published proposed a new way to stop light in its tracks at exceptional points, or places where two separate light emissions intersect and merge into one. But people are still fascinated by faster-than-light travel, like the warp travel concept. If this is possible, one day we will be able to send spaceships to the nearest star. Let's hear what you think is faster than the speed of light in the comments section below.